just over half a century, the motor car has developed from the chugging horseless carriage, preceded by a man with a red flag, to the silent, smooth-running, reliable machine that has now become a part of our everyday life. There are many factors which combine to make the wheels of a car go round, but the heart of these is the engine, and the heart of the engine is the cylinder block. Here, then, is the story of the care and precision that goes into the making of the cylinder block of a quality-first Morris car. Our story starts with the excavation of the basic raw material, iron ore. This iron ore is dug from the earth and is loaded into railway trucks. After a short journey, it arrives at the blast furnace sidings. Here it is joined by further trucks. Some of these contain limestone, while others contain coke. Limestone being used for the separation of impurities, and coke for melting the iron ore. In correct proportions, the ingredients are tipped into the furnaces. Here, under terrific heat, the coke gives off gases which act on the iron ore and reduce it to a liquid state. The result is molten iron. At the analytically correct moment, decided by the chemists, the contents of the furnaces are tapped and channeled off as required. This is done in a blaze of color and, of course, intense heat. As soon as enough has been drawn off, the furnace is sealed with a large pneumatic gun, which discharges a plug of fire clay into the hole. Before it goes to the foundry, the molten iron has to be cast into workable shapes. This is achieved by channeling the liquid metal into a series of small molds on a continuously moving belt. When the metal pigs, as the small molds are known, come off this machine, they have been cooled by a water spray. And the iron, which one day may be the cylinder block of your car, is ready to go to the foundry. Let's jump ahead for a moment and examine a cylinder block which has been cut in half. Note the intricate design of the interior. Molds have to be made for the exterior shapes, and sand cores will be made, representing the shapes of the various internal sections, including the crankcase and waterways. Here is a completed water jacket core. A core box, built up with detachable parts, is pushed under a pneumatic core blowing machine. Then sand, treated with oil, is blown into it at a pressure of 100 pounds per square inch. The detachable pieces of the box are stripped away, leaving the water jacket core. The smaller cores are made by hand. Here are examples of them, together with larger ones, on their way to the baking ovens. The cores for the crankcase and cylinders are made on the bore and crank core blowing machine, and the core box is built up with detachable steel parts. After it has been assembled, the box is pushed under the blower and filled with sand. It is then placed under a hydraulic ram, which ensures that the sand is tightly packed. The operation is repeated so that the sand forms a solid core. After packing, the box is dismantled. The sides and ends are taken off, leaving a replica of the interior of the mold in compressed sand. Thus we have the core for 2 cylinders and part of the crankcase. These cores join a moving line on their way to the baking ovens. An hour and a half later, the cores, baked hard, are taken out of the ovens. They are checked for dimensional accuracy, and any rough edges are smoothed off. Those that are passed by the inspectors are sprayed with a graphite mixture to provide them with a protective skin against the molten metal, which will soon be poured over them. When they have been dried off, they are hung on a pendulum conveyor and start their journey to the mold assembly line. A mold is now prepared for one of the 2 halves of the cylinder block. Over the pattern, which is accurately made, is placed a molding box, and they are securely clamped together. A mixture of moist sand, clay, and coal dust is poured onto the pattern while it is on a jolting machine. The vigorous action of the jolt machine shakes the sand into the crevices of the pattern until the pneumatic ram on the head of the machine descends and the sand is squeezed under tremendous pressure into a firm mass. The moulding box is withdrawn from the machine, and the shape of the exterior of the bottom half of a cylinder block is clearly seen in hard-packed sand. It is again sprayed, this time with a heat-resisting dressing. Now the time has come for the cores to be assembled into the mold. As each of them is placed in position, it is checked for accuracy of location. The water jacket core is assembled with the help of a gauge. After the gauge has been removed, the bore and crankcase cores are placed in position. As this mold is for a 6-cylinder engine, there are 3 cores. The end cores are fitted in position and gauged. And now the bottom half of the mold is ready for union with the top half. This is made exactly similar to the way in which the bottom half was produced. First the moulding box, then the sand, the jolting machine, and finally the ram. Before the final cores are placed in position, vents are checked to allow gas to escape when the molten metal is being poured in. The 2 halves of the mold are placed together, accurately located with large dowel pins. After being securely clamped, the completed mold is ready to be filled with molten metal. Meanwhile, the iron, which we saw at the beginning of our story in the form of pigs, is being melted down in readiness for the molds. A metallurgist is responsible for the quality of the iron. He keeps a constant check on the melting process through the inspection window, and this is what he sees. Actually, it is the molten metal trickling through the incandescent bed of coke. From every tapping, a specimen of the molten liquid is taken. After it is cooled off, this spoonful of metal is sent to the laboratory to be analyzed. The metallurgist makes a preliminary check of a sample. With his vast experience, he can make an approximation as to whether the metal is ready for final check. Metal chippings of the samples from the furnaces are sent to the foundry laboratories for analysis. After being weighed, they are dissolved with chemicals to check the various elements in the metal. In the laboratory is the key for the high quality of Morris castings. Maintaining an all-round-the-clock vigil, a group of technicians ensure that only the very best metal is built into Morris engines. They are in constant touch with the metallurgists in the foundry, and no tapping is made without their approval. As soon as the OK has been received, word is passed to the foundrymen, who by means of long iron rods unplug the cupola to release the molten metal. Out it rushes, and at this stage, powdered alloys are added as required. Once the ladle is filled, the cupola is plugged off with a wad of fire clay, and the ladle is taken to the conveyor on which the molds are poured. And now the finally prepared metal is poured into the molds. In a blaze of heat and light, from which the casters are protected by heavy goggles, the foundry becomes a veritable inferno during this last stage of the molding. From now on, the process is continuous, with fresh supplies of the molten metal being fetched from the furnace as each mold in turn is filled. At the cupolas, the other team of casters are filling their ladle, and meanwhile the molds are continuing their non-stop progress. After the pouring bushes have been removed, the molds enter a long cooling tunnel. At the other end of the tunnel, the molding boxes are lifted off, revealing the cast cylinder block. Of course, much too hot to handle. These are stacked for further cooling, and then by means of a conveyor, pass through a shot blasting machine, wherein all traces of sand are removed from the casting. Although already clean, there are still rough edges and flashes, which are removed by fettlers using pneumatic chisels and portable grindstones. After fettling, they are checked by inspectors using gauges to ensure that the casting is accurate. Next follows a pressure test, in which the casting openings are sealed and water forced in at 50 pounds pressure. This is to ensure that the casting is not porous. It is then given a coating of protective paint in a water-washed boule. And so to the modern Morris machine shops, where there are huge transfer-type machines which are controlled by electronic devices. These automatically pass the component from one machine station to the next. Small coloured lights continuously flash on and off as huge milling cutters, batches of drills and boring tools remorselessly work on the cylinder blocks. Later, the crankshaft bearing studs are inserted and the bearing caps assembled into position. Then the end faces a machine. At this stage, a further pressure test is applied to ensure the block is sound. Passing swiftly down a conveyor, the block is clamped into a jig and the cylinder bores are honed. Past one of the control panels, it enters a surface grinder where the top face is ground. The bores are now checked for accuracy with a gauge using compressed air. This ensures a correct diameter and a true bore. The cylinder block is at last ready to be built into an engine and is placed on conveyors on its way to the assembly section. Once on the assembly track, it is closely followed by 2 trays of components sufficient to complete one engine. Connecting rods, assembled to their selected pistons, are rapidly placed in position. A quick rollover, and the crankshaft is fitted. This is followed by the camshaft, complete with timing chain. The ease with which these operations are done is due in no small measure to the skill of the craftsman assembling them and the meticulous accuracy with which each part is made. The sump is bolted into position. The assembled cylinder head and valves drop quickly into place, and deft fingers place and tighten up the holding down bolts. The complete gearbox is bolted on, and then the engine is given a final check. Every little item has been scrutinized by inspectors on the journey down the assembly line, and now it has to pass its final test, this time on a test bed. Bolted securely in position, it is brought to life, and revolutions and output are carefully checked and recorded before it receives its passport to the racks to await the assembly into a motor car. And so we have seen what started out as a grabful of iron ore developed into a highly efficient piece of mechanism which provides Morris motorists with surging power at the touch of a button. Years of endless research and the most modern production methods have produced the quality first engine of the Morris motor car, undoubtedly an example of magic in metal.